Hello students, welcome at Educare. This is Bihani, and in this today's mathematics session we are continuing our determinant topic, that is determinants part 2. In previous session we have seen what is meant by determinant, how to expand the determinant, what is its symbolic form, what is its order, etc. Today we will see the important properties of determinant. There are about 6 to 7 properties. The first property is that if in the determinant rows and columns are interchanged, then the value of determinant remains constant. We'll take example for it. Suppose we have such determinant row wise 1 2 minus 1 3. Now if you interchange the rows and columns, you will get such new determinant. This first column becomes first row, second column becomes second row. If you find the value of this determinant, original determinant, that will be 1 into 3, that is 3, minus 1 into 2, that is minus 2, and this we are getting 3 plus 2 equal to 5. Now if you solve this determinant that obtained by interchanging rows and columns, we will get 1 into 3, that is 3, minus 2 into minus 1, that is minus 2, and can you see that again comes 5. So the first property is that if you interchange rows and columns of a determinant, we get the same value for that new determinant like it was previous. The second property is that if in the determinant, if we interchange any row and column, for example, if you have interchange first row with second row or first column with second column. See this example. Suppose the original determinant is like this 2 3 5 1, and suppose we interchange first and second row, that will be denoted by R1 interchanges with R2, and that will be now new determinant something like this. Second row becomes first row and first row becomes second row. Can you find the value of determinant first case? That is 2 into 1 2 minus 5 into 3 15 means 2 minus 15, that is minus 13. Now for this new determinant obtained by interchanging first and second row, we will have 5 into 3 15 and minus 2 into 1, that is minus 2. So can you observe the value of determinant remains same, only that plus minus sign changes. That means if in any determinant, if we interchange any two rows or even any two columns, then the value of determinant only changes by sign. Means if it plus become minus, minus become plus. Third property, in any determinant, if two rows are equal or two columns are equal, then the value of determinant is 0. For example, if you take this 3 into 3 determinant now, suppose first row is like this 3 1 1, second row is 2 1 minus 1, and third row also suppose 2 1 minus 1. So can you observe here, second row is equal to third row. Now if you try to find the value of this determinant, you know how to find, that is 3 into bracket this product minus 1 minus this product minus 1 minus minus, then it will plus. Then for second we are taking minus 1, you know, then this product 2 into minus 2 minus 2 minus 2 into minus 1, that is minus minus plus 2, and last plus 1 into this 2 into 1 2 minus 2 into 1 2. So can you observe it comes something like this 0. So that is the third property of determinant. In the determinant, if any two rows are equal or any two columns are equal, then the value of determinant is 0. Now we'll take the next property, and that next property is if any row of a determinant or any column of a determinant, if multiplied by some number k, then the new determinant value is k times that value of original determinant. For example, if you have such determinant 2 minus 3 1 4, and suppose you multiply first column by 2, means we are doing 2 into c1. Now 2 into c1 means 2 into first column, that will become now this new determinant like this. 4 2 will be first column, after multiplying to second column, no change. Now what we do here, we try to get the values of these two determinant. First determinant value will be 2 into 4, 8 minus 1 into minus 3, minus 3. So can you see that comes 11. Now the new determinant obtained by multiplying 2 to the first column, then we get 4 into 4, 16 minus 2 into minus 3, that is minus 6. And can you see this is the what value? 22. And then it is changed to 2 times. So 11 multiplied by 2 getting 22. So what is that property? If any row of a determinant or any column of a determinant, if multiplied by some number, then the new determinant is that number times the original determinant. So that was the fourth property. Now we take the fifth property, and the fifth property is that if you split up any row of a determinant into the sum of two numbers, then the new determinant is the addition of two determinant, something like this. Suppose we have this original determinant 5, 3, 4, 2. Then do you know, we can suppose the first row split up. This 5 can be written 2 plus 3, and this 3 can be written 2 plus 1. Second row, no change. Then this determinant is the sum of such two determinant. This first number from each bracket will be written here. I mean first determinant will be written from that bracket, and the second will be written here 3, 1, while this second row is unchanged. Now what we do, we find the value of original determinant, that is before split up. 5 into 2, 10 minus 4 into 3, 12, and that comes to be minus 12. Now let us check this addition. First determinant of this new determinant, 2 into 2, 4 minus 4 into 2, 8 plus the second determinant value 3 into 2, 6 minus 1 into 4. Now what will this total? Minus 4, and this 6 minus 4, that is 2. So this total comes minus 2, while this 10 minus 12 also it is minus 2, which I have written previously minus 12, but it is in fact, can you see, 10 minus 12 is minus 2. So these both values are equal. What is that property? If any row or any column, I have shown here row, if split up into two such numbers, then we get two determinant addition equal to the old determinant's value. Then the next property, that is the property number 6. If any row or any column, if multiplied by some number, and those products are added to the corresponding elements of other row or other column. If row taken, operation with row. If column taken, operation with column. Then the value of new determinant remains constant. How it is? See here. Suppose we have such determinant 1, 2, minus 1, 3. And suppose to the first column, if you multiplied by 2, that will call as 2C1. And suppose these products are added in the second column, that means it is something like this. That is given as, this is as same as 2C1 plus C2. Means first column each element multiply by 2, and those products add in the second, by which we are getting change. The first column, second remain unchanged, 2, 3. 2C1, that operation will be like this. 2 into 1 plus C2 means this 2. So 2 into 1, 2, 2 plus 2, that is 4. Then here for second element, 2 into minus 1 plus 3, that will be minus 2 plus 3, which is 1. Now we find the values of both determinant and see they will be same, exactly same. For example, this first determinant 1 into 3 minus 1 into 2, that is minus 2, and that comes to be 5. The second determinant D is constant, that mentioned here. 1 into 3, 3 plus this minus 1 into 2, minus 2, that comes 5. Then first determinant that was multiplied by 2, and second addition 2 into 1, 2 plus 2, 4, and the second that comes here something like this. Then we are what getting here? 2 into 1 plus 2, that is 4. 2 into minus 1 minus 2 plus 3, that is 1. Then we are getting 4 into 3, 12. 12 minus 2, that is 10. So this is how the value remains constant. The last property is the triangle property called, and it is something like this. Triangle property of a determinant. If the determinant has its elements above diagonal 0 or elements below diagonal 0, then the value of determinant is equal to the product of the diagonal elements. For example, as a symbolic, we have, suppose this the determinant a1 0 0, b1 b2 0, c1 c2 c3, and the other determinant is a1 a2 a3 0 b2 b3 0 0 c3. Can you observe? In this first determinant, the elements above diagonal are 0. In the second determinant, the elements below diagonal are 0. If you solve this determinant, you will get this as product a1 b2 c3, means product of diagonal elements. Here also you will get a1 b2 c3, that means one and the same. So that is the triangle property of determinant. These all properties are very important to solve the problems or the questions on the determinant which are properties determinant. Many times the question is asked, solve the determinant without expansion. Then at that time, to simplify the determinant or to get its value or to simplify the determinant, we require to use these properties. If you like this video, share with your friends and subscribe to our channel and get notification by pressing the bell icon. Thanks.